Hello, everyone. Hey, good afternoon. Good afternoon. Sorry, I am a few minutes late. I am jumping in from another meeting.
Okay, sir. No issue.
No. Yeah. So I don't know if
I will
somebody is going
introduce
to
them.
meeting, or is that something that
Yes, sir. Sorry.
is somebody is going to anchor the meeting?
Yes. I'm going to enter. Wait.
Sure. Right.
So, welcome to all in the second session of our FDP. It is my honor and privilege to introduce our second guest, that is Mr. Jayakkumar A Krishnasamy, CTO at AILA CDS Pune. With over 20 years of experience across the manufacturing, insurance, and telecommunication industries, Sir holds master's degree in artificial intelligence and machine learning from Scalar and postgraduate diploma in business analytics from Symbiosis International University. Sir has developed deep expertise in IoT machine learning, big data management, technical architecture, and programming in R and Python. Also, Sir has worked as a data scientist and AI trainer at Freelance Pune, Deputy General Manager at STL Sterilite Technologies Limited Pune, Vice President Product Development at Swiss Ray Bangalore, also Business Development and Pre-Sales at Cognizant Chennai, also Software Engineer in Exaware Technology Chennai, and he also worked on various positions in John Deere also. So with this, I now invite Mr. Jayakkumar A Krishnasamy sir to begin the session. Over to you, sir.
Thank you, Priyanka. Thank you, everyone who has joined. Thanks for the kind introduction. I am Jayakkumar A Krishnasamy. You can call me Jay. So today's session that I chose to take was around what we call as RAG systems, RAG systems, and Agentic RAG systems. I know there is a pattern with which everything is going, and I am assuming that the introduction of AI, about AI, machine learning, and AI agents, and the differences between them has already happened. This is my assumption. You guys can correct me if I'm wrong. If something is beyond what you comprehend, please let me know. I'll try and bridge that gap briefly. But today's whatever session that I'm going to have for the next 1.5 hours is going to be focused on what we call as RAG systems. Can I ask like open questions to the audience? Like if you guys can answer it in the chat, we can make it a bit more interactive, if that's okay with all of you guys. So I'll start with this open question: is does anyone know anything? Do you know what RAG is? What is RAG? RAG? Okay. So there is a lot of no's coming. Any yeses? Retrieval augmented generation. Yes. The RAG stands for retrieval augmented generation, and why it's so special and what it can do is something that we will see now. Okay. So before I get into RAG and all the details about RAG, I also specific answers from huge database. Yes. Sweta says specific answers from huge database. That's pretty much it, right? Like when you have huge amounts of data and databases, and specifically, okay, I have this question. Specific answers from huge database. All our RDBMS database does the job, right? There can be huge databases with RDBMS type systems, DB2 mainframes, Oracle systems, any kind of databases that we do. They have huge amount of database. So what is special here? LLM and custom DB. Okay. Okay. Custom database. Okay. So I would say it's a I wouldn't say custom. It's a combination. So when you have a situation where you have unstructured data working together, this typical RDBMS systems, what it does is it throws all the bunch of text and image files and everything that you give into something called blobs, okay, binary large objects, and they just throw it in a file or a set of file or into a file system, and they just create a link with the structured data to the unstructured data. That's pretty much it. So all it can do is that if you have a traditional RDBMS system, you'll be able to link a record to a file, and that's about it. You may potentially retrieve it back, but you won't have any intelligence about like the contents of it. And if you want to search inside the document, you don't have any other options. There are some restrictions. So this is the traditional RDBMS world. Then came the world where people started talking about NoSQL databases. NoSQL databases where you don't have to write a SQL query to query the database. So it was, I call it a lazy developer database. Okay, meaning developers who are lazy enough to learn about RDBMS and database systems created this idea of just capturing things in terms of schemas, which they write it in classes, and they just wanted to download that structures into files and then have that associated data sitting along with it so that you can pull it out. The typical JSON structures, XML structures that you have to deal with when you write programs and stuff like that. They didn't want to deal with RDBMS structures in terms of primary key, foreign key relationships and checks and balances and integrities and stuff like that, because they wanted to move fast with development. So that's why I call it the lazy developers databases. But that's just my term. But various different technologies came through, which is like CouchDB, which is MongoDB, which is now called, I think it is called Atlas DB. The various different types of databases came, which handled these type of very different style of holding data. But end of the day, they were still structured data, which means that even a JSON structure is a structured data. Only thing is you just you didn't call it as columns and rows and put values inside these things. So that is the only difference. But it was still structured. So truly unstructured data started emerging when HDFS systems, the so-called Hadoop systems, started emerging in the field. So Hadoop, I don't know if you guys heard of Hadoop. This is many years back. At the time, it was one of the biggest technologies. It's just distributed system, but you can arrange files in a linear fashion and you can scale it in commodity hardware. Earlier, that distribution was deeply held with IBM and these big companies. Hadoop opened it up, right, a little bit. Now things have evolved beyond that, right? Right now, you have various different types of technologies which have come. For example, Databricks has come up with certain technology levels where you can have Parquet files, and on top of that, you can have metadata, and the metadata can be shared among other systems. Among all this, development of databases came a situation where large language models started coming in, and large language models said that, okay, if I have to read something, I will read it only in terms of embeddings called vector embeddings. Okay, so they called it vectors and vector embeddings. What these things are and things like that, I will show you in a while. But once these vector embeddings started coming in, and large language models were basically what we call as AI these days, started answering questions that we have, and it tended to take data from these large language models. But these large language models were built by these large companies like OpenAI, Claude, and other people, Gemini, with a certain cutoff date in mind. So basically, they collected all kinds of data from World Wide Web and everywhere. They basically created these models from this data, and they threw away their data. Data is not required anymore once you created the model. But the limitation is the model's ability to answer questions to you is limited to the data that it's been trained on, which means there is a cutoff date. Let's say 2025, December 2025 is the cutoff date for a model. Anything that you ask about anything that happened in 2026, the model is plain and simple, not capable of answering your questions. And provided it knows something about it. So it will, but the models, these large language models, are trained using a technology called reinforcement learning with human feedback. So that essentially means that the model is trained to please human beings, you and me. It is not meant to give you the right answer. Okay, so that is one of the biggest mistakes people do, is they treat large language models like Google search, and they believe whatever the model is saying. So that is very dangerous. Okay, because these models are trained to please human beings because they need to survive. Okay, so even if they don't have an answer, they will not say they don't have an answer. They will concoct something and they will give you an answer based on the old data and patterns that they can find in the models. And this is dangerous for especially for companies which tend to take decisions on top of that, and definitely other, personally, you and me also. It's not a good idea to completely rely. Can we have everybody on mute if that's okay? Thank you. Okay, so this is also a problem, right? This hallucination was a problem. Now, other problem that started coming up is these large language models were good. They are good. They can answer questions. They are capable models. But they don't have information about, first of all, the latest information we have. Next thing is companies, big companies or small companies, anybody, they needed to use their own data, and they wanted to leverage large language models on top of their data. Now, if it is 1 or 2 files, you and I, we are familiar, we can just drag and drop it into ChatGPT and say, hey, here's the file, tell me anything XYZ about this, and it has a capability to do it. But what if we had 10,000 files? What if you had 1 lakh files, 10 million files, right? It's not possible, right? And why it is not possible? Because large language models, whichever way they are getting exposed to, they have limited memory space, which we call as context space. Now, all these terminologies are important when I start explaining RAG and how it works and all these terminologies are important. That's why I mentioned that if anybody has done some prior work on AI, if not, probably in your upcoming sessions you might understand a little bit more. But for this session, this is important to understand, is that this contexts are getting created whenever you interact with large language models. Now, this context never go away for one particular session. That means if you put in bad context information, you're going to get bad results. Okay, and it is limited. This context window is limited. Every model has this limitation. If you are interacting with ChatGPT or Claude through the browser, you will have a conversation with it and it will start answering that. So input you are giving is called an input context. Then the output that it is giving out in big verbose content is called output context. Then that is not the only context. The thinking it does, the reasoning that it does based on your questions and using its own data, it is also part of the context. So they generally for commercial reasons and for capturing your and my data, they make it look like it is free, and they give large enough context for us to use. But that there is a limitation for it. Okay, there is a limit to this context. So if you are working with any of the frontier models these days, 1 million characters is there that is available for everybody. But that is also a limitation when you deal with 10,000 documents, 20,000 documents, 1 lakh documents, and things like that. And also, as I mentioned, if we start putting bad context, the model will start giving you bad results. So the question is, how do you put good context into the model? Okay, so that your answers are right. So all these things need to be engineered. It is not by chance, it is engineered. Now, when you want to engineer this such a system that works with you in these situations, then we have to build something called the RAG system. It's called retrieval augmented generation. So large language models, as I said, has its own limitations. And beyond these limitations, if you want to provide some additional documentation or content and things like that, how do you make large language models respond correctly to what you have with you, okay, without running out of memory and blowing up your builds and things like that, okay? That's the trick here. Okay, so okay, now I can share the screen and some content. Okay. What I will rely on is it's an existing. So we have a AI first coding course in our company, and I'm going to rely on the course content for this session. Why? Because it allows me to go and show you different concepts very, very quickly without breaking a sweat, because it is already there. So this is essentially a course. Module 2 is free for everybody, so you can go to this site and get to the course and see how AI agents are developed. Okay, so this is the initial module level, but then after that from this point onwards, it's behind a paywall. But you can build a prototype, and when you build agents, you can build prototypes using 2 different technologies. One is called the NA10, which is typically for people who are not comfortable with coding and who want a visual way of learning stuff. So for them, we have this section where it is NA10. But if you are comfortable with coding and you can work with Python, we have a Python version of the same thing. So it is up to you guys. What are you interested in? It takes into all the details. Okay, so I will not get into any of these details, but I will stick to the concept that we wanted to discuss, which is RAG. Among everything else that we discussed, RAG is the concept that we are going to look into. Okay. So I'm just going to borrow the content from this course that we have. All right. So, oh, by the way, I'm just opening the slides, but there are videos and text also. So, I mean, if those of you who want to watch it as a video, you can watch it as a video. Those who want to read it, you can read it. Slides are generally used by me or my instructors to teach. So let's talk about RAG fundamentals, okay? So when we talk about RAG fundamentals, one thing that we have established now since our discussion is LLMs has its own limitations. And when you have additional data you want to put and make the power of LLM to work on your data, and your data size is beyond 3 or 4 files, you have a volume of data, then you have a case for building a RAG solution. A lot of companies are looking for this type of solution, okay? And we do consulting and work on this space also. What are the learning objectives? We will look at what retrieval augmented generation is, and why AI agents need to answer questions about your documents. So when I talk about AI agents, it is not your large language models. These are agents. Again, these are structured agents which work with any kind of large language models. And I said there are two different ways which are there. One is Python based or TypeScript based or any other programming language based. Agent creation is possible on different frameworks. Or another framework which is visually possible is, one of them is NA10, but there are lots of other solutions out there in the market where you can build all these types of agents. All these things are available in YouTube. You already know potentially. So idea is that AI agents are slightly action-oriented elements, okay, modules. Large language models have an ability to just answer your questions. They don't take actions. AI agents have a capacity to take actions, okay? And that's the difference. And these agents that can take actions get supported by the knowledge from your documents through the RAG system. So they work hand in hand together, okay? When we talk about RAG systems, you need to understand something about vector databases. I already mentioned that large language models like to work and interact with something called vectors or called vector embeddings. You put a bunch of vectors together into something, it's called a database, basically. So like any other database where you have columns and SQL database and NoSQL database, vector database is also another type of database. Guys, I am assuming because of the answers that I got, most of you are not familiar with these terms. So I'm trying to be as grounded as possible, and I'm not rushing through. If it is boring, and if you guys already know about it, please mention that in the chat and I can speed up, no issues. Okay. Is the pace okay with everyone? Yes. Okay. 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 Let's go ahead. Okay. So, so when we talk about, thank you so much. Thank you for everyone who are responding. So when we talk about vector databases and stores, you need to pay attention to embeddings and the dimensions. And what makes it fast, okay? The whole trick here is that even if you have millions of records, whether you are able to respond in a matter of milliseconds, okay? I'm talking about milliseconds. How do you do that? Okay, so you need to understand the game behind all this to be able to achieve that performance. Okay, so all right, so we will also walk through a complete RAG flow from documents to embedding. I don't know if we will have time to build one and show it to you and demonstrate it for you. I have the code, and the codes are all there in the course itself. All you have to do is download it and run it yourself. But I don't know if we will have the time to do it, because RAG is one and then Agentic RAG is another. So in this session, we are going to cover two topics. So, you know, it's subjective if I will be able to show you a demo. Now, but I can show you where you can get, and then probably the code that we have, I can potentially download it and share it with the group, and all of you can have this code. So, okay, so then building a working RAG pipeline with the NA10. So again, NA10 is a tool. It's as I said, it need not be NA10. It can be any other programming tool also. But the idea is that it is going to watch the flow that we have created and sharing with you. It's already a slightly advanced flow. It's not a typical RAG solution. This is something that you can actually use, or companies can use. Basically, what it does is so you have a drive, right? And new files will come into the drive, and it will keep watching the drive. When new files come, it processes it. Okay, when it gets updated, when files are getting updated, it knows that it has updated and processed. If you delete it, it will delete it. So it sort of syncs the database with the drive, right? So something like that, and processes them and stores them. Now, storing them can be in a database. Now the database typically can be a Postgres database. This is what I prefer. Postgres database. It can be a SQLite also if it's too small. But if it's a Postgres, you have to enable an extension called PG Vector, which means a vector database on PostgreSQL. Vector databases, there are lots of commercial solutions available. I think Pinecone, Quadrant, VV8. At the initial stages, there was something called FAS from Facebook. Plenty of people came up with plenty of solutions. But tried and tested, PostgreSQL has always been the database for many years now, and it's free, and it has PG Vector, which is a vector embeddings, and the solutions that we are building, it's working just fine. It's super fast. I don't find a need to spend money and subscribe and take something like a Pinecone or a Quadrant. Of course, the game will change if you're dealing with millions and billions of documents and things like that. Then you will have to go to that scale. But typical situations for any medium to any anybody who's dealing with less than about like a lakh of documents, it's good enough. Okay. Now that is PostgreSQL if you are running it in locally. Now same PostgreSQL, you don't want to run it locally. But if you want it to be hosted in cloud, there are various different solutions for that. One of them is Supabase. Supabase is they have a free version, so you can use the free version of Supabase. They take care of most of the things about security, about row level security, etc., etc. So they have all these kinds of fancy stuff. Underlying bottom line, it is still PostgreSQL. Okay. So either ways, you use Supabase or PostgreSQL is one and the same. The next thing that you need to pay attention to is what are the concepts that are involved in RAG. One of them is called chunking and metadata collection and RAG tool configurations that leads to agentic search. Okay, so that is something as the second part. Metadata collection, we'll see if it comes, but that is also typically needed into agentic RAG, but chunking is definitely needed for RAG. So what is chunking and all those things, we will slightly see. I will not spend too much time on this, okay? So RAG, so what it does to your agent, okay? Basically, you can chat. Can we mute ourselves, please? Thank you. Okay. All right. So, as I mentioned, when you have external knowledge that you have with you, and you want large language models to be able to access it and work with it, but you don't want to share all the documents at the same time, you want to only select certain specific set of documents or sections of those documents to be shared, which is what chunking is all about. Even if you have a document and if you have chunks, only certain chunks will be shared with the document with the large language models. So that means all your data, all your sensitive data, you're not going to share with large language models at the same time. So that is a bit of security there, but that's the nature of a RAG-based solution. I'll just skip through these things. Okay. Are we already talking about? We are talking about, okay. Even though we talk about RAG solutions, as I said, that you can add these documents, RAG solutions themselves has some disadvantages. Okay, what are they and what are that? We will see it later. But when we create a RAG-based solution, where RAG is okay for searching and providing information from your internal documents. But what about documents that are not in your premises? You might want to go out in the web and search and things like that. So that's why you have to Generally, when you build AI agents, you also, when you have a RAG solution, you also have a web search solution, which is not necessarily required. In many cases, we will not, but in some cases we do. So AI agents can work with multiple tools. Okay, RAG for it is a tool. So is search. So is everything else that it's going to work with. So there are many tools that you can define for an AI agent. So I'm just saying that when we build a solution with AI agents, RAG is not the only solution we build. We build additional solutions also. One of them being web search tool. Web search also, there are options of relying on external APIs to do the search, or you can have a local web search engine running, which for free, which is called CRNG. You can try that. But there are options, is what I'm essentially saying. Brave API that we see here was free when we created this. Now probably they are restricting it, but there are also other free APIs that are available. Okay, so this is already we covered. RAG does not replace large language models. It feeds into large language models. Okay, how do vector databases work? Basically, there are three concepts: embeddings, dimensions, and nearest neighbors. Okay, embeddings is what forms the crux of the vector database. Okay, when you create a vector database, you use the embeddings, you put them together. Okay, but once you put them together, so when I say when you put them together, what I mean by that, I will explain a little bit. Okay, so when you interact with, or when you provide documents, okay, to any large language model, what it does is it converts the text into what we call as embeddings. Embeddings are a bunch of numbers, and that's why we call it as a vectors. The bunch of numbers represents the text that you have given, and which we call as tokens. Combination of tokens forms your sentences, and that means combinations of these vectors forms your sentences. And each vector, as I said, has it's a column, right? It's a column, which means there is in a column there are multiple rows, and each one is called a dimension. So the length of the column determines the breadth of your vocabulary, let's say. Okay, the more words you put, the more size you need to accommodate, right? So it's an analogy. Okay, but these vectors and these embeddings are not created only from one word perspective. It actually carries connections and context across all the embeddings that are there in the vector database. So they are already connected with each other, okay, in the form of numbers, and these numbers know each other. So this means that there will be variations and small variations between these numbers, which puts things together. Okay, so this all goes back to the original concept of transformers and attention layers and things like that, how large language models are even built. Okay, that is beyond the topic for now. But basically, when the model building happens, this is what is happening, right? So you have a bunch of numbers in terms of the vectors, and these vector numbers are calculated by the model. And why it is calculating this? Because it is trying to find association between words. Okay, and these transformers with attention heads basically determines which words are more important than the other. Okay, so this is the whole crux of what large language models are. But when we create all these numbers become vectors, and with these vectors have dimensions, and this dimensions ka size determines how large the information you can put together in the space, and that determines the power of the model. So the larger the model, the larger the size, the powerful the model, more it's going to cost you. Okay, so that's the simple dynamics that you need to understand. I don't want to get more technical into this. So when we talked about dimensions, we are familiar with 2-dimensional, 3-dimensional. These are multi-dimensional vectors, which means it's in a hyperspace. which we cannot see because human beings have a limitation of seeing only 3D objects. Hyperspace, hyper objects you want to see, you have to only imagine, because this is our mind's limitation. But mathematics doesn't have this limitation. It can see hyperspace, or at least represent things in hyperspace. So what it all means is that these spaces is called vector embedding spaces, because the space is now having a lot of embeddings and a lot of words. And it also, as I said, these embeddings have relationships between one word to another. And this is just what you see in the screen is just a representation of that, okay, for us human beings to understand what it is. Models and math doesn't require this representation. They know it. But for us to understand, this is about, so what I mean by associations is that in simple terms, when we talk about various different topics, each topics can belong, each words can belong to a topic. So for example, if somebody is talking about laptops and MacBooks and desktops and gadgets and all these things can be put together in clusters. It's just a representation, okay? Don't take it literally. But technically, if you want to represent it, if you represent it in terms of how you represent a vector, right? As a line with an arrow, which that means it has a direction. And that direction means two words together can form, an angle between them, right? And depending on the angle that you see between these two words, to these vectors, you can determine how similar. Cosine similarity. This is a way to determine if a word is closer to the next word. Is it related to each other? Okay, and this is an important concept that has been applied in this type of spaces. Okay, to determine, okay, how is guitar connected to laptop versus how close gadgets is connected to laptop, or MacBook is connected to laptop. Okay. Technically, they are both devices. Guitar is a device and MacBook is a device. But to the word laptop, MacBook is more closely associated than the guitar, right? This is learned. We learn it by our experience. How will a mathematics model learn it? It learns by the distance, and the distance is called the cosine distance, and the distance is calculated by the vectors and the angles between these vectors. Okay, so so this way you can create multiple different sections, which creates multiple different associations, and it knows which one is far away from each other, and it also can have hierarchy. So like you can define something called a building, and then you can say a building can be anything, right? It can be a hospital building, it can be a school building, it can be your house, it can be anything. Anything is a building, right? Then you say a doctor is associated with that building. Then what do you think about it? Probably that building is a hospital. You make that association, right? So those types of contextual association is what large language models are doing. That means even if you don't have, if you're asking about a question that the model is not trained on, it is able to make those associations, okay, based on the words that you type. That's the danger that we are talking about. The model doesn't necessarily need to have the data that you are looking for. It can make those associations and it will try and answer that question. And that's why it does that. This is all, conceptually I'm saying. But then generally there are these techniques called nearest neighbors, sophisticated versions of nearest neighbors, I will say, called ANN models and things like that. That is all used to essentially zero down on even. So basically when you have a word, you want to predict the next word. That's how large language models work. But how will it predict? It will predict among a bunch of words, and those bunch of words need to belong to a particular neighbor in the cluster. And it has to do it fast, right? It cannot. So these things happen really, really fast. So this is basically the difference between how a traditional search, keyword search based work and the semantic search, which RAG does, works. RAG basically does the exact same thing what we said, what large language models do. Because basically what you're doing with RAG is you're taking your documents, you're converting them into embeddings, and you're putting those embeddings in a vector space. And this vector space and embeddings is what the large language models understand. So the large language models can work with your RAG at a much faster rate than you loading a document into the large language model, because internally it will convert that back into embeddings and vector spaces, and then it will work. Okay. So I want to quickly go to a space where, okay, these are all RAG and all these concepts, but how do you build it? Okay, what are the main components for building a RAG pipeline? Okay, so RAG pipelines have two different flows. One is called the ingestion pipeline, and another one called the query pipeline. Most of us are familiar with the query pipeline, which means that we ask questions, the answer comes to us, nice and nice. Okay, that's the last bit, the large language models, LLM questions and context, and you get an answer. This is the last bit which you are most familiar with. But there is this ingestion pipeline also. So basically, ingestion pipeline takes care of the process of loading the content. So when you have documents, you take those documents, you convert them into chunks. Chunks can be fixed length chunks, or it can be semantically determined, or there are various different kinds, okay, so of chunking. So basically we chunk the documents with overlaps and things like that, and we create these embedding models. These embeddings models are vectors, go into a vector database, and this vector database is typically stored, as I said, Postgres or a Supabase with PG vector extension. PG vector extension is the extension that is coming with Postgres to handle vector databases. This also means that you can store RDBMS type data in a Postgres database along with the vector database. Okay, so now the equation is that you are not limited to only storing vector databases. You can have typical RDBMS, because even SQL databases has its own power. They have done wonderfully well for so many years, and they have served us so well for so many years. They are still consistent. So, for example, now let me talk about the limitations of RAG. Okay. Now, if you have only RAG database, you can ask questions which are semantically related, okay, and association based on things like that, and it will have an ability to answer, even if you are not asking for a strict your question has to exactly match, as a restriction is not there. It has the ability to go beyond your limitation of asking queries. It can still try and find the right answer, and large language model is very good at that. That's why we love it. But the limitation is, for example, if you have a table of, let's say, 1 million columns, and you want to ask a large language model, okay, this is a column of numbers, calculate an average about it of this thing, 100% it will create a mistake. Okay, it is not good at that type of operation. Okay, so those types of aggregation related operations, or you want to list a list of items that you have in your database, and you don't want to miss out on anything, and your table has 1 million or 2 million records out there. Large language models cannot handle that, because their inherent nature is to do sampling. Okay, they always sample stuff. They will not take the whole thing. They will always sample. Even if you load your entire file into a large language model and say, hey, analyze this and tells, it does sampling. It does not read unless it's very small, with one chunk you get the whole information, then it doesn't matter. I'm talking about large files, okay? It does sampling. So it will not go through the entire file. If you're meticulous enough, you will start noticing it. Now, if you are trying to analyze a file which you don't have any expertise or idea about, and you completely rely on large language models to tell you what the file is all about, that means you're taking a shortcut. Then you will not find out the mistakes that it is doing. You will tend to believe that whatever it's saying is right, and you will take it. And this is a trap. So you need to be aware of these things. Okay. So that means you can't make these mistakes when it comes to data that you are taking from something. Let's say you want to know so average of something, or what is the the highest of something, right, or lowest of something, or something like that. These are business-related questions. You need to be accurate. You cannot be wrong about it. So that means you need a combination of these two. So that is why when we design these solutions, we always have a combination of these two, and we know what to put where. Okay. Now, typically, these types of things you won't hear from YouTube channels. Okay. We do it, and that's why we are sharing it with you. So the point is that so this is the limitation of RAG. So the limitation of LLM is carried on to RAG. RAG also does sampling, and that means you cannot ask questions, or if you don't rely on RAG to answer questions which are like aggregation related questions, or which we have to be meticulous about it, and you have to be accurate and all that, right? No, that's not the right solution. So the trick is how to make them to work together. So so this is the ingestion pipeline. Then the query pipeline starts. Once the ingestion is there, vector database is there, then the query pipeline, the users start asking questions. The question is also embedded in terms of the embeddings, so that the dimensions have to match. Okay, so the vector database dimensions, the dimensions, and the large language dimensions have to match. Otherwise, you will not get the right answer. So the dimension matching is absolutely important. And then the semantic search comes into picture, which is the nearest neighbors, which is what RAG is great about. The searched information. So basically, when you ask a query, the search is done on the vector database. The related chunks based on the semantic search is given to you, and only that context, which we call the good context, is passed on to the large language models along with the question, and the large language model has no other option other than to work with your data that you have given. Okay. Well, that's what we assume, but still that there can be breaches and things like that. But then we try to limit the hallucination problem that we have with the large language models, and you get an answer. So this is the whole pipeline. Okay, this is the central piece. Rest of the content here will go into the details of how do you design each of the components. And the rest of the things goes into how do you set up the Superbase content, because this will keep on going. Okay, so this is a big slide, and it also talks about how to build a RAG pipeline in A10, because I'm being conscious about the time I'm taking, because we are already about 45 minutes into this, and this is halfway through. So I really would like to take a pause. If you guys have any questions, I will answer if anything needs to be handled. So typically what happens is when we give these courses, we also give content that people can download and work through. So this is about how to work through those content. Okay, so there are PDF documents, Excel spreadsheets, CSV files. How do you do processing? How do you do chunking? How do you insert this into a Superbase? How do you set up Superbase, which you saw? How vector databases are created? Which options to select? Okay. How do you handle metadata, which is critical? As I said that when you're processing documents, you also collect metadata. Okay, you don't blindly create vector databases. You collect documents and metadata. What metadata you will collect about your files that you're loading, file IDs, file title, file URL, and potentially you might want to collect what type of file it is and things like that, metadata about the file, whether it is a doc file, PDF file, JPEG file, it could be an image, any other file, right? MP3 file, MP4 file, whatever file, right? So you want to collect all this information. You might also want to collect additional information if you want. That's a different topic. Okay, so but idea is collect metadata and store this metadata into a table, which we call as documents table. So this is our style of doing things. Okay, so when you create a documents table, then you have in Superbase or PostgreSQL, you create a function called a match function. This needs to be determined. How to build all these things? We potentially can share the code base with you guys, and you can work through this. That is the Superbase version. This is the local version of PG vector. Okay, suppose if you don't want to have a super base version, you want a local version, which means the PostgreSQL is inside, you are handling yourself, which maybe you have a Docker container and put your PostgreSQL running from there. How do you do it? Okay, how do you create local file triggers, which means that it's not Google. So basically, this is the local version of the cloud version. Okay, so it covers all those things. So I'll not get there, go deep into it. Okay, so in conclusion, because this is like the halfway mark, I need to go to the agentic structure. Halfway mark mein kya hai? So RAG, I mentioned, is a knowledge extension system to large language models. It deals with vector databases because it deals with vectors and embeddings. Embedding models have its own dimension space, and you have to match the dimensions of your embedding models with the dimension of your large language model, which is going to interact with this. If there is a mismatch, you're going to get garbage. Okay. So then RAG workflows we talked about, it has two different workflows. One is the ingestion workflow and the query workflow. And then in the ingestion workflow, we talked about chunking. Chunking has various different types of chunking. Fixed versus overlapped versions also is there. And contextual chunking is also there. Many sophisticated things are there within chunking itself. Then apart from that, we talked about variations of hosting the RAG database. One is the Superbase version, Postgres version, which is the local version, which you can build. Okay, yeah, from a large language model wise, OpenAI, Claude, and all those, the cloud version, you can have a local version running. If you have a GPU based system, you can have Olama and other type of large language models, which they give it to you, which you can run it on your own. So you can save on those things. So there are lots of models that are out there, both local and cloud-based. What is happening is people are going more towards cloud-based models than the local ones, because like really you cannot compete with the pace with which the cloud-based models are improving. Especially a lot of small models have come, which are potentially able to give the performance of a costlier model. Like when I say costlier model, my benchmark is Claude. But there are a lot of small models like Qwen 3.7, I think, Kimi 2.7 and things like that, right? So these are much smaller models. They are quite capable, but they are not thinking models. So you would want to have a mix of these things. So these are kind of details that are out there, where how do you create efficiency even within this ecosystem. I will stop here. I will, if anybody has any questions, if any topics you want me to go deeper, you let me know. Did this section make sense? Okay. Is any topic here that you guys want me to go into? Anything you want me to double click and go? Otherwise, I will go into Agentic RAG. Okay. So I'm getting only yes as an answer. So I guess everybody are good with it. Okay. Let's talk about, okay, so before I go further, this is all theory, right? Isme maza nahi aayega. So point is, everything, there is a code base here, okay? I kind of like, if you have access to this, you will have, I'll try to show you something before I start the next topic, okay? I may not be able to run it though, because I don't have the time for that. I can show you what it looks like. Okay, this is innate. Am I sharing my screen? Okay, this is our company's N8N instance. And this is my personal one. So I have various different things. So I've created this RAG folder for you guys. I've already downloaded the content. Okay, so let me just show you the content that is out there. Okay, I can stop sharing again. Okay, 1 second, guys. I'm going to show you. Okay, if I am too fast, okay, I'm sorry, guys, because there's so much things are there now, little time. So generally what happens is the code that you saw when you download it, you get a zip file. This is for topic 4.1, and it already has. This is for N8N, okay. And it already has these sample files and things that you can run, and the database that you want to create in either in a PostgreSQL or in a Superbase, whichever. The SQLs are there. It will create all the tables and the matching functions and all those things. The files that you would use to test all of them, how to build that, that is all there. The workflows are there. The README is there. README will tell you exactly what to do with it. Okay, so it is already laid out for people who have access to this. Okay, so show you, if you open the README, it will tell you exactly what you need to do, what are the instruction sets and things like that. That's why I'm not bothering explaining, showing you too many things, because that content is already there. I'll just open these workflows and show you what it looks like. Okay, so that will give you a perspective in N8N. So I want N8N. That's my N8N. Did I close it? Okay. So this is our N8N instance. You can go in here. So I'll create a workflow, and I'll just import from the file that I have. It should open somewhere here, and it is in downloads. 4.1. Okay, so you have the ingestion workflow, and you also have the agent workflow. So let me import the injection workflow. Okay, so the injection pipeline is already there. Everything is already set up for you in terms of how N8N works through. Okay, all you need to do is pull those files, set those fields, and just run this. So it will work, and it will, essentially the pipeline steps are already there. It's what it will do is it will ingest all these files for us. Okay, once you do this ingestion, then you can go to the next workflow, import the next one. Ingestion we did, right? This is the agent chat. This is the chat version. So once you have ingested it, all the Postgres connections and everything, it will know it. You'll have to set this up. Instruction to what to set and everything, it's already pre-built. Some of them are already pre-built. But whatever you need to do to set this up and things like that is already there in the instruction sets. Then you can just basically chat with your agent. So this is like a chat trigger. So you can chat. I haven't run any of these things, so it won't work. But once you set this up, it will work. So this is a typical RAG solution built on a visual flow tool like N8N. The Python version is also there, right? And okay, so this is section, yeah, this is 4.1. 4.2 is about 4.2 is about Agentic RAG. As I said, like I have videos. If you like to watch videos, you can watch, you can play. I'll work with slides because I'm talking. Okay. Do you guys need a break or can we start? We have about an hour.
You can start, sir.
Okay, fine. I mean, if somebody needs a 5-minute break or 10-minute break, we can give. It's okay. It's okay, fine. We'll go. Okay, so Agentic. So this is the advanced version of RAG. We'll call it advanced version, but just a bit more complicated version of RAG. That's it. But it does deal with AI agents. Okay. So I remember I mentioned RAG, if your solution that you build is just another tool to an AI agent. Now we will talk about a little bit about AI agents. So there are two limitations about RAG. We already mentioned it about naive RAG. Structured data doesn't do well. Next problem is full document. When you load a full document, basically when you have to interact with any document, right? No matter what document it is, you don't need the entire document in memory to be able to answer query that you're asking. You might ask a query that might be in, let's say it's a book. Let's just take a book. Would you ask a query that requires the entire book? No, right? When you have a question to ask and when you want an answer, you don't ask a question that covers the entire book. If you want to, then even if you do ask that question, then you're limited to only the index portion of the book, basically. What you end up asking is that very pointed questions and small sections of or different sections of the book might have the answer to your query. And you need only those things loaded in context, not the entire book, right? So this needs to be kept in mind, okay, when we build these systems. So how Agentic RAG works? So Agentic RAG means you will have multiple retrieval strategies instead of a single lookup path, basically, right? So you have one database. This is all my documents. You fetch only from this. That is not the strategy. You'll have multiple retrieval strategies because the data might be spread out across multiple places. And this is typically the case where we end up using Agentic RAG solutions. Or agentic, yeah, we call it Agentic RAG, but essentially it is agents. RAG is just one piece of it. Then there are other pieces that are there available for the agent to work with. Okay, so there is, even though I say that, even RAG, there are multiple types of RAGs also. We will get there. I mean, if time permits, we'll get there. So, okay, so the first example we saw creating documents table, and the document table had all the documents in rows, and it had a matching documents function, which will basically work with the index that is there, and it will find the matching documents that are based on your questions that you're asking, and based on that, it will answer your queries. But there are additional two schemas that can be added to the structure. One is called the document metadata. The other one is called the document rows. Where are these two things useful? Suppose if you have an Excel file, okay? Excel file, typically comes under the files category, where the way you deal with a document, Word doc file or a PDF file, people tend to deal with Excel file also, but Excel files generally have structured data, right? It has tables, columns, etc. If you think about it, it's actually a table. Now, what is the best way to store an Excel file? Okay. Now, when you create an Excel file, what will be the type of questions you will ask from an Excel file? Will it be the same type of questions you will ask from a doc file or a PDF file? Will PDF files or doc files you have might also have, okay, this is like a slightly advanced version, okay? I don't want to confuse you guys, but they also might contain tables. Now, if you want to extract those tables separately and manage it separately, that is also possible, but that's slightly advanced version. But let's keep it simple. What are the type of queries you will ask for from an Excel file? It will be different from what are the type of queries you will ask from a Word document and a PDF file, point blank, right? So typically the questions you will ask is, which is related to numbers, which is related to aggregations, which is related to, exact lookups of something, etc. That is not the typical way that you will deal with docs files or PDF files when you are dealing with text, okay, or for that matter, images. So how do you need to store the Excel files? Now, naturally, it has to be different. It has to be stored in a slightly different manner than how you're storing your docs files. So how do you store it? All right, so that is the question. So there are two extra tables that we create. One is called the document metadata table, and the other one is called the document rows table. So document rows table. So basically, first of all, we differentiate between the files itself. If it's a docs file, my PDF file, and XLS file, everything will be dealt differently. So there will be multiple pipelines running. Okay. In the ingestion process itself, that means you are going to collect multiple types of metadata for different types of files. Docs files, you will collect different types of metadata, and for XLS files, you will collect a different type of metadata. Bottom line, this is what you need to understand. Now, once you create this, then you can ask one of the simplest problems you would face when you create a naive RAG system is that even if you have a 10,000, as I said, 10,000 documents are there. If you want to list out this 10,000 documents, the RAG system will not be able to do it. It's the most obvious question, right? So when you load a million files, you want to know what are the files that you have loaded. You want the list of files there, right? This doesn't necessarily it's not available with the RAG, because how RAG stores is it converts everything into embedding, and it creates associations with these embeddings, and then that is all good from a association point of view. But you want the list of documents, then it will struggle. It will not give you a full list. That means you will have to create separate approach to create a list of documents. Now, since we have this metadata tables, we'll be able to do this. Okay, so these metadata tables that we are talking about, right? This document metadata, the document rows, these will actually supply the necessary data for answering some of these questions. So if you ask to a list document, it will fire differently. It will not go to the vector database. Okay, it will go to the metadata table, and it will fetch all the list of documents that are already recorded in the metadata. It will answer, and this decision is made by the agent, and that's why it is called the agentic RAG. Okay, and that is why we say that it is multi-retrieval strategy. Okay, so then you might ask a question about getting full file content. Or you might, and RAG also suffers from this. Once it is chunks, it has a very hard time putting all of them together. Okay. Then other thing is, you might end up creating different types of files. Okay, so for example, for different types of Excel files. Okay, I'm keeping it simple. Okay, so let's say you have different types of Excel files. All Excel files will not have the same columns. Schemas will be different. The data will be different naturally. Now, if you are asking a type of question which is natural language form way, how will the agent know which particular Excel file to fetch and what type of data it needs to fetch from it? Right? It has. So you need to be able to do that association also. That is also being done in the RAG system. That means query on the fly, a query will be written. When you are natural language, you are asking questions, the agent will write a query which is appropriate to answer the question that you're asking for. Okay, and it has a bunch of tables that it has to choose from. All of them will come from the in a combination of document metadata, documents, and the document rows tables. Mainly documents and document rows tables will answer that question. Now, this type of modeling, this is data model, okay, which I am telling you is a data model. Typically, you won't find this outside. This is again, it's our method that we are sharing. Now, it solves a lot of problems, by the way, because we kind of solved all these things. Now, recognizing why non-deterministic retrieval, letting agents choose this approach and produce more accurate answers. So basically, the point is the agent recognizes deterministic versus non-deterministic retrieval methods, and it chooses the right approach to answer the question. And that's why you get the most accurate questions, spending less amount of money, okay, or minimal amount of money that to achieve a job. So limitation of naive RAG, I already mentioned all these things to a large extent. Structured data and math related questions, if you ask, LLMs in general will struggle. If they get it right, that means there are a lot of loading happening behind the scenes, or processing happens after the answer has come. So they also do this pre-processing before the answer to you. Okay, so they look for these type of things. Okay, so this is the example that I was talking about. Imagine you have a table of 2000 rows of revenue data. It can be more typically. LLMs are bad at math. Chunking splits the tables. So if you remember the chunking method, if you apply to tables, you will have, like, say, 50 records in one chunk and 50 other records in one chunk, and you're asking for a total. It might retrieve the chunk or it might not retrieve the chunk. Okay, and then Uber say, if you want a sorted list, then it is gone. Okay, you cannot do sorting. So these are limitations. Okay. Lost context from chunking, right? I mentioned it, it is coming here. So you understand, right? So naive RAG is like reading a book by looking at random paragraphs. You won't have any continuity. It is by nature, it is random. And then you will miss all these connections, how this is related to that and all these things. So Agentic RAG lets an agent decide whether to read paragraphs, read the whole book, or run a calculation on the data instead, which means what type of retrieval method is required for answering a question. So this is like the advanced version. As I said, it basically, why it is advanced, it removes many of the negatives that we find in the naive RAG system. And so typically when an agentic RAG is attempting, so this is an example of how it behaves. And let's say if you want an average of a new customer, so these examples are there in the files. So similarly, the files that I've shared, 4.0 also has a set of files that you can load, you can run, and you can look at the queries and you can see how it behaves. And whatever you see in here, you will see there. Then you can put your own data and you can experiment. Okay. So then the point is, agentic RAG attempts. So let's say, I think this 98, it is coming from a pure RAG system. But the agentic RAG, when it appears, it writes this particular query that you see on the screen. It selects the average of new customers. and it gives you out specifically the number is 101.25. This is the exact answer. You can check in the given examples that are there. So this is just a verification. Now, whatever I am saying now, you can test it and see. You don't have to believe me, but this is how it works. Basically, what happens is you have a naive RAG, you have a user question, vector search, partial chunks. You typically get a wrong answer. By chance, you might get a right answer, but then most likely you will get a wrong answer. But in agentic RAG, all the time you will get the right answer. Okay, because it's going to when you ask this type of question, it's going to know that it's not going to use vector search, it's not going to do full document search, it is going to do a SQL query. It knows that, it chooses that, and gets the answer. This is essentially pretty much the whole concept. So definition of agentic RAG is straightforward. You give the agent the ability to explore your knowledge base in different ways, depending on the question you're asking. Again, right? The user asks those questions. So again, more of the same comparisons. For those of you who wants to go through this again and again, you can do that. The same concepts are still applied. So the RAG concepts of semantic search is still applied here. Full document retrieval, that's why you have the list of documents and the get the file contents type functions that are written on the databases. So similarly, match documents function you wrote, similarly, you will write some extra functions for this to get these things. And then the query documents rows. So this is large language model writes the query, by the way. Okay. Depending on the questions you're asking, the same of similar things. Okay. So when you set up a database, you're looking to set up the documents table, which you probably did in the previous version. If you run it, I think you will do it in this version also, either way. But in this version, you will create these additional tables. One is the document metadata table, this is meant to store high-level metadata information. Why you need this high-level metadata information? As I said, you will be loading docs files, XLS files, PDF files, etc. You need to know the metadata to know that if it's an XLS file, then you will have to have a different approach to retrieve out of it, and you need to go to a different section to retrieve that information. This is for this is the type of metadata that is collected. Metadata means that's ID, title, created, URL, and the schema. Schema is the columns in your spreadsheet file. Okay, so that means you can have any number of Excel files in this system. It's already normalized. Okay, so the schema column is the clever part. Regular document for regular documents which are not having any schema, that stays null. Typically when you have so you might be collecting any kind of data. Okay, so this is an example of having a meeting and minutes of the meeting is collected and you're storing that as a document for your records, if that's the case, and you want to use RAG for that. So typically columns look like this, months typically like this. These structures are there. That structure that you saw there, that the actual rows from the spreadsheet. So one is to store the schema. So you're storing only the header column. Rest of the data, right, is stored in the documents rows, and that association is there with the metadata. So that means you can have n number of rows in an Excel file. All those rows will also getting captured, and the metadata is there in the metadata table. So that's the leverage that we are having, and all the row data is stored as a JSON-B object, which is JSON binary. It's one big key value pair store. Extremely efficient. This type of storage can be extended to storing images also. That's the advantage of this. Okay, so you okay, here's a typical thing. So this is I talk about JSON-B, it is coming right after this. So basically JSON-B is powerful, and it just talks about all the different things that you can do with it. So, okay, so we have an updated pipeline. So the same 4.1 pipeline you have, what you saw, we will see the 4.2 version of it, and you will see the difference between them, where the metadata files are coming and how it is getting stored and all that type of stuff. Okay, so I just want to make sure that I cover everything. Extra steps for spreadsheet files, insert table rows. This is done through a loop through the spreadsheet, and it does. So this is all in the workflow, and the update schema to document metadata that I will show it to you in the drive in the workflow. Okay, so this is I think we started at 5. Oh, we have a stop at 5, right? I thought it's 5:30.
Yes, sir, but you can complete your topic.
Okay.
It's 5 o'clock.
Okay. So I'll try to stick to the time. Okay. So building tools, listing documents. So these are the type of queries that you will get written. So the point is, see, there's no point in me showing all these things. This information is already there. I will rather show you the workflows and how it works, because you can see all these. I just want to show how the structures are created. These are like things that you can see when you get into the depths of things. All this information is there. It also tells you how to verify how it works. It tells you what to watch for, what you will get as an answer. It sort of spells it out for you. The option of having Superbase and PostgreSQL is also coming after this. Okay. So key things that you need to note is the limitation of naive RAG. It fails with structured data, point blank. Agentic RAG gives multiple retrieval options that is practically useful. We added 2 more tables, which is one for metadata, document metadata, and document rows. This is a prototype structure. In real world, you could end up creating more complicated structures, but the requirement has to drive it. 3 powerful tools. So function definitions. One is list documents and get full contents or query a document. So these are functions that we will be defining it, and also the so these are the tools that we will define for the agentic RAG, but the description of the tool is also important, which is the most important thing most people miss. So when we write a tool, or you think of it as like a function, right? It is a function, but that function is written for human beings typically. But for agentic systems to understand by reading that function, you will have to give a good description for it. Okay. So that also is there, how to write those descriptions so that the agent at runtime, it is not struggling for choosing the right tool. Okay, so that also matters. Everything matters. Seconds, as I said, seconds matter, milliseconds matter. So how do you achieve it? By these small nuances that I'm mentioning about. That's how you achieve. So I will go back to. So in 4.2, also you have similar structures. We will see these 2 workflows. Okay. I'm sorry, I'm not giving enough space for questions. Okay. I should have. Okay, so this is the ingestion flow. Okay, way more complicated than the basic one, but it is not. I will explain to you. Okay, basically it looks for file types, and depending on the file types, it does different processing. And once it does the processing, it aggregates that information together. Once it aggregates, so basically depending on whether it is a document, it starts loading into different sections So this is the metadata collection part, and the actual document insertion part. Okay, so it looks complicated, but then the only thing is that I've added this portion and this metadata collection portion. Rest of the things are the same. Okay, between those two things. Okay, so the other piece, one more, and one. Yeah, agentic response, right? Now you see the magic now. Okay, so the agent has an ability to connect to multiple different functions. So I will have to zoom in for you. Because so this part you're familiar with, agent, this is chat memory, this is Postgres store, this is where we stopped in the last part. These three functions are added. One is for get full document, write a query, and this is about list documents. So if you look at the content of what is written here, this is the query that is written. So it's just a typical SQL query. Okay, so it is essentially written. It gets the contents from documents, and it sort of gives you that. I think I can go to the. Okay, the interesting part will be how it writes. So, as I said, the important thing is the description part, right? Let me see if I can expand this. Right. So this is the description part, which essentially spells out to the agent how it needs to, deal when it has to write a query. So what are the different things that it needs to look for, and where it comes from, and etc. This is optimized for the data that is already loaded. So this is, we already know these things, right? Now these can be generalized also for situations where you don't know how many files you have and all that, right? So this can be generalized for this particular use case. It is written like that. Now this is for listing files. This is a typical straightforward query on documents listing all the files. So that's why we have the documents folder. Okay, so typically when you run these things, you can see this in the SQL in your Postgres database or your SQL database. You will see records showing as you process these things. Open those two screens and then run these things. You will see all these things happening live in front of you. So I'll stop here, and for the content and things, whoever is in touch with me, I will share it, and you can pass it on to the rest of the audience. I will just stop here. If any questions, we are on time, but I can spend some more time for questions. Was this useful? What do you guys? Okay, so for the courses, if you want, so you can actually go to the site called AIFCC. Okay. So you can go to this AIFCC. You can see the plans. The first one is free. You can just go through that, and then you can buy them essentially. So it's the fundamentals is about 7,000. and then the builder and the architect level. So basically, whatever I showed you, okay, whatever I showed you is till this portion, and like not even this. 2 sections in one of the modules is what I showed you. There are plenty more out there. So this is coming from not theory, guys. This is practical. We are building these systems and we are delivering solutions to companies. So none of these things go very, very intense. Okay, so it will go deeper. Our intention is that anybody who wants to build any prototype or anything, like if you are a college student or anybody, if you want to get a job, you have to show people what you can do, right? And unless you know how to actually build something and publish something and put them in as a portfolio, you'll not be able to do it. From builder onwards, we teach you how to deploy it in cloud. So those you can go to AILA.com and you can enroll. And we do 2 workshops for people who enroll in fundamentals, workshops like this, and answer questions. And if you have any trouble, problem, anything like that, we try to solve and all that. Yeah. So those of you who are serious about taking AI agents and build a career out of it, these are things. Builder is there that takes you all the way to document processing or even Claude skills. And then after that, it becomes very, very serious. It's an architect level course where you're actually building some serious stuff from this point onwards. This in itself is good. This fundamentals and builders is more than enough. Somebody had any questions? If somebody raised their hand. Okay. Hope you guys had a good time. Okay. Hope it was.
Thank you, sir.
Priyanka, yeah.
Yeah, thank you, sir. Today's session helped us to understand the importance of RAG in enhancing AI responses with reliable document-based information and how vector database and embedding enable efficient semantic search. Also, the complete RAG flow from document processing to generating intelligent responses through LLMs, practical implementation of RAG pipeline using N8N, Google Drive and Supabase. Also, significance of chunking metadata management and knowledge-based configuration for building effective AI-powered systems. So your ability to explain this advanced concept in a simple, practical, and engaging manner has greatly enriched our understanding and inspired us to explore AI-driven teaching and learning solutions. Thank you, sir.
Thank you so much, Priyanka, and thanks everyone for the opportunity to interact with you guys. And yeah, we'll be in touch. Thank you, guys.
Before we conclude, I would like to propose a vote of thanks. I take this opportunity to express my heartfelt gratitude to the management of WIT, respected Principal Dr. S.R. Gengi sir, the organizing committee members, our esteemed resource persons, and all the participants for their active involvement and support in making today's session success. So with this, I formally declare that day 2 of our faculty development program comes to an end. Let's meet again tomorrow sharp at 2 p.m. for yet another insightful session. Thank you once again. Have a pleasant evening. Thank you, sir. Attendance link will be shared in WhatsApp group. Okay, and also it is shared in chat box. Thank you.
Thank you, sir.